Supply starts with a single seller combining capital and labor services to produce a desired level of output. It confronts a wage and rental rate for capital services which dictate the cost of any particular combination. Minimizing cost is a matter of finding the lowest ISO cost line tangent to the isoquant for the desired level of output, here C sub B. The firm's problem in choosing inputs to minimize the cost of achieving a particular level of production is analogous to the consumer's dual problem to utility maximization, that is, minimizing the expenditure necessary to achieve a particular level of utility. To bring together costs and production mathematically, we start with a Lagrangian. And we find the three first-order conditions. So I take the derivative of the Lagrangian with respect to L, set it equal to 0. Now stop the video and you do the other two first-order conditions. By analogy to the consumer's expenditure minimization problem, the second-order conditions at a local minimum require quasi-concavity of the production function. Solving either of the first two first-order conditions for lambda, we get lambda is equal to, say, W over Q sub L, which is equal to the change in cost over the change in output resulting from an increase in L, and that's just marginal cost. The same for the ratio of the rental cost of capital to the marginal product of capital. Combine the first two equations to get the tangency condition. And if we substitute this, solve for, say, k as a function of L, and substitute this back into the production function to solve for L, we get L and K as functions of input prices and the desired level of output. Substitute these back into the expression for costs, and we get the cost function, which conveys all we need to know about the economically relevant portion of the production technology and the responsiveness of the firm to changes in input prices, all emerging from cost minimization. And we end up with